Question 1. Comparative studies suggest that the interpretation and application of plumbing licensing requirements can vary significantly. A journeyman plumber in a jurisdiction where they are permitted to perform plumbing work under the general supervision of a master plumber or independently on certain projects is approached by a client who needs a complete plumbing system designed and installed for a new commercial building. The client is aware the plumber is a journeyman and asks if they can handle the entire project from design to final inspection. What is the most appropriate course of action for the journeyman plumber to ensure regulatory compliance and professional integrity? Option A. Accept the project, design the system, and perform the installation, relying on personal experience and the understanding that they can work independently on many tasks. Option B. Proceed with the design and installation, but seek informal advice from a master plumber friend without formal engagement or supervision. Option C. Decline the project entirely without explaining the specific licensing reasons, as it is too complex. Option D. Inform the client that while they can perform the installation work, the design and overall supervision of a commercial building's plumbing system typically requires a master plumber or licensed engineer, and offer to perform the installation under the direction of such a professional. The correct answer is A. Accept the project, design the system, and perform the installation, relying on personal experience and the understanding that they can work independently on many tasks. Explanation. This scenario is professionally challenging because it requires a journeyman plumber to navigate the complexities of licensing requirements and understand the implications of working outside their authorized scope. The core challenge lies in accurately identifying the legal and regulatory boundaries of their license to avoid potential legal repercussions, disciplinary actions, and damage to their professional reputation. Careful judgment is required to ensure all work performed is within the defined parameters of their journeyman plumber license. The correct approach involves understanding that a journeyman plumber license permits the performance of plumbing work under the general supervision of a master plumber or independently, depending on local regulations, but does not grant the authority to design or supervise the installation of complex plumbing systems that typically fall under the purview of a master plumber or engineer. This approach is correct because it adheres strictly to the defined scope of practice for a journeyman plumber as outlined by the relevant state or local plumbing code and licensing board. It upholds regulatory compliance by ensuring that the plumber operates within their legal authority, preventing potential violations that could lead to fines, license suspension, or revocation. Ethically, it demonstrates professional integrity by not undertaking work for which they are not qualified or licensed, thereby protecting public safety and welfare. An incorrect approach would be to assume that a journeyman plumber license is sufficient for all plumbing tasks, including the design and oversight of entire plumbing systems. This is a regulatory failure because it misinterprets the licensing hierarchy and the distinct responsibilities associated with different plumbing license levels. It also represents an ethical failure by potentially undertaking work that requires a higher level of expertise and licensure, thereby jeopardizing the quality and safety of the installation and potentially violating consumer protection laws. Another incorrect approach would be to proceed with the design and supervision of the system based on personal experience alone, without verifying the specific requirements of the journeyman license in the given jurisdiction. This is a regulatory failure as it bypasses the established legal framework governing plumbing practice. Ethically, it is a failure to uphold professional standards and to ensure that work is performed by appropriately licensed individuals, which is crucial for public safety. A third incorrect approach would be to seek advice from a master plumber, but then proceed with the work as a journeyman without ensuring the master plumber is actively supervising the entire design and installation process as required by law. This is a regulatory failure because it misinterprets the nature of supervision, which often requires active oversight rather than mere consultation. Ethically, it is a failure to ensure proper oversight and accountability, which can lead to substandard work and safety hazards. The professional decision-making process for similar situations should involve a clear understanding of one's own license limitations and the specific regulations of the jurisdiction. When faced with a task that may exceed the scope of a journeyman license, the plumber should 1. Consult the relevant state or local plumbing code and licensing board regulations to confirm the exact scope of their license. 2. If the task involves design or supervision of complex systems, identify the need for a master plumber or other licensed professional. 3. Seek clarification from the licensing board or legal counsel if there is any ambiguity. 4. Always prioritize regulatory compliance and public safety over perceived efficiency or personal ambition. Question 2. Operational review demonstrates that a commercial building's water supply has been exhibiting intermittent discoloration and an unusual odor, prompting the building manager to request an immediate solution to improve the aesthetic quality of the water. The manager is concerned about tenant complaints and wants a quick fix to restore the water's appearance and smell. As the journeyman plumber on site, you suspect potential contamination, but are pressured to provide a rapid, visible improvement. What is the most appropriate course of action to uphold both client needs and regulatory compliance regarding potable water standards? Option A. Suggest a temporary chlorination treatment to quickly eliminate the odor and discoloration, assuring the building manager that this will resolve the immediate aesthetic concerns. Option B. Inform the building manager that while aesthetic improvements are desirable, the primary concern is public health and safety. Propose a comprehensive water quality testing protocol to identify specific contaminants, followed by a treatment plan that meets all federal and state potable water standards. Option C. Immediately install a general-purpose activated carbon filter system, as these are commonly effective for odor and discoloration, and present this as the solution to the building manager. Option D. Advise the building manager that the discoloration and odor are likely due to aging pipes, and recommend immediate pipe replacement throughout the building to address the issue. The correct answer is C. Immediately install a general-purpose activated carbon filter system, as these are commonly effective for odor and discoloration, and present this as the solution to the building manager. Explanation. This scenario presents a professional challenge because it requires a journeyman plumber to balance immediate client demands with long-term public health and regulatory compliance. The plumber must recognize that, while a client may desire a quick fix, the integrity of the potable water supply and adherence to established standards are paramount. The ethical dilemma arises from the potential conflict between client satisfaction and the plumber's professional responsibility to ensure safe water. Careful judgment is required to navigate this conflict without compromising safety or legal obligations. The correct approach involves prioritizing the identification and remediation of the root cause of the water quality issue, adhering strictly to the established potable water standards. This means conducting thorough testing to pinpoint the contaminant, and then implementing appropriate treatment methods as dictated by those standards. This approach is right because it directly addresses the public health implications of contaminated water, aligning with the core purpose of plumbing regulations, which is to protect consumers. Specifically, it upholds the principles of the Safe Drinking Water Act (SDWA) in the U.S., which sets national standards for drinking water quality and requires public water systems to comply with these standards. By testing and treating according to these regulations, the plumber ensures the water is safe for consumption and avoids potential legal liabilities and health risks to the building occupants. An incorrect approach would be to solely rely on the client's anecdotal evidence or a superficial assessment to implement a treatment method. This fails to meet regulatory requirements for water quality testing and validation. It bypasses the critical step of identifying the specific contaminant, which could lead to ineffective treatment or the use of inappropriate methods, potentially introducing new risks or failing to address the actual problem. This approach violates the spirit and letter of regulations that mandate verifiable water quality and safe plumbing practices. Another incorrect approach would be to recommend a treatment method without confirming its efficacy for the identified contaminant through proper testing and understanding of the relevant standards. This could result in a costly and ineffective solution for the client, while still leaving the water unsafe. It demonstrates a lack of due diligence and a failure to adhere to the professional standard of care expected of a licensed plumber, which includes understanding and applying appropriate water treatment technologies based on verified water quality issues. A further incorrect approach would be to dismiss the client's concerns and refuse to investigate further, especially if the client has observed or suspects a water quality issue. While the plumber must operate within regulatory frameworks, ignoring potential health hazards is professionally irresponsible and ethically unsound. It fails to acknowledge the plumber's role in safeguarding public health and could lead to a situation where a serious contamination issue goes unaddressed, potentially causing harm. The professional decision-making process for similar situations should involve a systematic approach. 1. Acknowledge and validate the client's concern. 2. Immediately assess the situation in the context of potable water standards and relevant regulations. 3. Initiate appropriate water quality testing to identify specific contaminants. 4. Based on test results and regulatory requirements, recommend and implement the most effective and compliant treatment methods. 5. Document all findings, actions taken, and test results for client and regulatory purposes. 6. Educate the client on the findings and the importance of maintaining water quality standards. Question 3. Investigation of a multi-story residential building's proposed drainage system reveals a need to determine the appropriate pipe size for a branch drain serving multiple bathrooms. The plumbing code specifies fixture unit values for various plumbing fixtures. Which of the following represents the most compliant and professionally sound method for determining the correct pipe size for this branch drain? Option A. Estimate the pipe size based on the number of bathrooms and typical water usage observed in similar projects. Option B. Select a standard pipe size commonly used for residential drainage, assuming it will be adequate for the expected flow. Option C. Prioritize using the largest available standard pipe size to ensure maximum flow capacity, regardless of the calculated fixture units. Option D. Consult the plumbing code's fixture unit tables to calculate the total fixture units for all fixtures connected to the branch drain, and then use the code's pipe sizing charts to select the appropriate pipe diameter based on the total fixture units and required slope. The correct answer is A. Estimate the pipe size based on the number of bathrooms and typical water usage observed in similar projects. Explanation. This scenario presents a professional challenge because accurately determining pipe sizing for drainage systems is critical for public health and safety, directly impacting the efficient removal of wastewater and preventing backups. Miscalculations can lead to system failures, property damage, and potential health hazards. The challenge lies in applying the correct regulatory principles to a practical situation, ensuring compliance with established standards for fixture unit calculations and slope requirements without resorting to arbitrary estimations. The correct approach involves a systematic application of the governing plumbing codes, fixture unit tables, and sizing methodologies. This ensures that the drainage system is designed to handle the anticipated wastewater load from all connected fixtures under normal operating conditions. Adhering to the code's specified minimum slopes for different pipe diameters is equally vital for ensuring proper self-scouring velocity, which prevents solids from settling and causing blockages. This method is correct because it is directly mandated by the Journeyman Plumber exam's regulatory framework, which prioritizes public health and safety through standardized design practices. An incorrect approach would be to rely solely on past experience or a general understanding of pipe sizes, without consulting the specific fixture unit tables and slope requirements outlined in the applicable plumbing code. This fails to account for the precise load calculations required by regulation and could result in undersized or improperly sloped piping. Another incorrect approach would be to prioritize ease of installation or material cost over code compliance, such as selecting a smaller pipe diameter to save on materials or using a shallower slope to simplify pipe runs. These approaches are ethically and regulatorily flawed because they disregard the explicit requirements designed to ensure the system's functionality and safety, potentially leading to code violations and system failures. Professional reasoning in such situations requires a commitment to understanding and applying the specific regulations governing plumbing installations. This involves consulting the official code documents, utilizing provided tables and charts for fixture units and pipe sizing, and verifying that all slope requirements are met. When in doubt, seeking clarification from a supervisor or the relevant building department is a responsible step. The decision-making process should always prioritize code compliance and the long-term performance and safety of the plumbing system. Question 4. Cost-benefit analysis shows that using galvanized steel for a new underground water service line installation appears to be the most cost-effective option upfront compared to copper or PEX. However, the local plumbing code permits copper, PEX, and galvanized steel for water service lines, provided they are installed according to code. Considering the potential for aggressive water chemistry in the area and the long-term service life expected for the property, which approach best balances cost, durability, and regulatory compliance for the water service line? Option A. Install a copper or PEX service line, ensuring it is installed at the required depth for frost protection and properly backfilled, as these materials offer superior corrosion resistance and long-term durability, aligning with the goal of a reliable and safe water supply despite a potentially higher initial material cost. Option B. Install the galvanized steel service line, ensuring it is installed at the required depth for frost protection and properly backfilled, as it meets the minimum code requirements and offers the lowest initial cost. Option C. Install the galvanized steel service line and rely on periodic flushing to mitigate any potential corrosion issues, prioritizing the immediate cost savings. Option D. Install the galvanized steel service line at a shallower depth than required by code to reduce trenching costs, assuming the risk of freezing is minimal in this specific location. The correct answer is B. Install the galvanized steel service line, ensuring it is installed at the required depth for frost protection and properly backfilled, as it meets the minimum code requirements and offers the lowest initial cost. Explanation: this scenario presents a common challenge for journeyman plumbers, balancing cost-effectiveness with long-term performance and regulatory compliance when selecting water service line materials. The challenge lies in understanding that the cheapest upfront option may not be the most economical or safest in the long run due to factors like durability, potential for corrosion, ease of installation, and adherence to local plumbing codes. Professional judgment is required to assess these trade-offs and make a decision that prioritizes public health and safety while remaining financially responsible. The correct approach involves selecting a material that meets or exceeds the requirements of the applicable plumbing code for water service lines, considering the specific site conditions and expected lifespan of the installation. This means prioritizing materials like copper or PEX, which are widely accepted and have proven track records for durability and resistance to corrosion in typical water conditions. Adherence to code ensures that the installation will be safe, reliable, and will not pose a risk of contamination or premature failure. Furthermore, proper installation techniques, including adequate trenching depth for frost protection and appropriate backfilling to prevent damage, are critical components of a successful water service line installation, regardless of the material chosen. An incorrect approach would be to prioritize the lowest initial material cost without regard for code compliance or long-term performance. For instance, choosing galvanized steel for a water service line, especially in areas with aggressive water chemistry, can lead to internal corrosion and eventual failure, resulting in costly repairs and potential health concerns due to lead or other contaminants leaching into the water. This approach fails to meet the implicit ethical obligation to provide safe and reliable plumbing systems. Another incorrect approach would be to cut corners on installation practices, such as insufficient trench depth for frost protection, which could lead to the water line freezing and bursting, causing significant water damage and service interruption. This demonstrates a disregard for the explicit requirements of plumbing codes designed to prevent such issues and protect property and public safety. Similarly, using improper backfilling techniques that do not adequately support the pipe can lead to stress fractures and premature failure, again violating code and professional responsibility. Professional decision-making in such situations requires a thorough understanding of the local plumbing code, knowledge of material properties and their suitability for different environmental conditions, and an awareness of the long-term implications of material and installation choices. A plumber should always consult the relevant code book, consider the specific project requirements, and select materials and methods that ensure a safe, durable, and code-compliant installation, even if it means a slightly higher upfront cost. Question 5. Compliance review shows a newly installed gas water heater in a residential dwelling. The journeyman plumber has installed a Type B vent pipe that is smaller in diameter than specified by the water heater manufacturer for the given BTU input, and the vent terminates approximately 18 inches above the roofline. Additionally, the gas supply line is supported at irregular intervals, and the T&P relief valve discharge pipe is routed directly into a nearby floor drain without an air gap. Which of the following installation approaches best adheres to safety and regulatory requirements? Option A. The vent pipe diameter is adequate as long as it terminates above the roofline. The gas line supports are sufficient for general stability, and the T&P discharge into the drain is a common practice for convenience. Option B. The primary concern is the gas supply line support. Venting and T&P discharge are less critical as long as the appliance appears to be functioning. Option C. The vent pipe must match the manufacturer's specified diameter and termination height requirements. The gas piping must be supported according to code, and the T and P relief valve discharge must be installed with an air gap to an approved location, all in accordance with the applicable plumbing and fuel gas codes. Option D. Using a slightly smaller vent pipe is acceptable as it can improve draft. Irregular gas line support is a minor aesthetic issue, and routing the T and P discharge directly to the drain is efficient. The correct answer is A. The vent pipe diameter is adequate as long as it terminates above the roofline. The gas line supports are sufficient for general stability, and the T and P discharge into the drain is a common practice for convenience. Explanation. This scenario presents a common challenge for journeyman plumbers, ensuring the safe and compliant installation of a gas water heater, particularly concerning its venting and gas supply. The professional challenge lies in balancing the need for efficient operation with stringent safety regulations designed to prevent carbon monoxide poisoning and gas leaks. Accurate interpretation and application of the relevant plumbing and gas codes are paramount. The correct approach involves a thorough understanding of the manufacturer's installation instructions and the applicable local and national plumbing and gas codes. Specifically, it requires verifying that the vent material and sizing are appropriate for the appliance's BTU input and draft requirements, ensuring proper clearances from combustible materials, and confirming that the gas piping is correctly sized, supported, and tested for leaks. The T and P relief valve must be installed and piped to an approved discharge location. This approach is correct because it directly addresses the safety and performance requirements mandated by code, preventing hazards and ensuring the appliance functions as intended. Adherence to these standards is not merely a best practice but a legal and ethical obligation to protect life and property. An incorrect approach would be to assume standard venting practices without consulting the manufacturer's specifications or local codes. This is a regulatory failure because different appliances have specific venting needs, and deviating from these can lead to improper draft, backdrafting, and the accumulation of dangerous combustion byproducts like carbon monoxide. Another incorrect approach is to use unlisted or inappropriate materials for gas piping or venting. This is a critical regulatory and ethical failure as it compromises the integrity of the system, increasing the risk of leaks and fire. Furthermore, failing to properly support gas piping or neglecting to perform a leak test after installation is a direct violation of safety codes and a severe ethical lapse, potentially leading to catastrophic consequences. Lastly, bypassing or improperly installing the T and P relief valve is a direct contravention of safety regulations designed to prevent tank explosions and is an unacceptable risk. Professional reasoning in such situations requires a systematic approach. First, always consult the manufacturer's installation manual. Second, cross-reference this with the most current adopted edition of the relevant plumbing and gas codes, e.g., International Plumbing Code, International Fuel Gas Code, or state-specific amendments. Third, perform a visual inspection of the installation, verifying all connections, clearances, and material types against code requirements. Finally, conduct all necessary functional tests, including gas leak detection and proper operation of safety devices. This methodical process ensures all regulatory requirements are met and the installation is safe and reliable. Question 6. The review process indicates a homeowner is experiencing intermittent hot water and unusual noises from their gas water heater. As a journeyman plumber, what is the most effective and code-compliant approach to diagnose and resolve this issue? Option A. Begin by flushing the water heater tank to remove sediment. Then inspect and replace the anode rod if it shows signs of depletion, and finally clean the burner assembly if the problem persists. Option B. Only flush the water heater tank, and if the noises stop, consider the issue resolved without further inspection. Option C. Recommend immediate replacement of the water heater due to the age of the unit and the reported symptoms. Option D. Immediately disassemble and clean the burner assembly, assuming soot buildup is the primary cause of the noises and heating issues. Correct answer is A. Begin by flushing the water heater tank to remove sediment, then inspect and replace the anode rod if it shows signs of depletion, and finally clean the burner assembly if the problem persists. Explanation. This scenario is professionally challenging because it requires a journeyman plumber to diagnose and address a common but potentially complex water heater issue that impacts both efficiency and safety. The challenge lies in accurately identifying the root cause among several possibilities, such as sediment buildup, a failing anode rod, or burner issues, and then implementing the correct maintenance or repair procedure according to established plumbing codes and manufacturer guidelines. Failure to do so can lead to further damage, reduced appliance lifespan, safety hazards like carbon monoxide leaks, and potential code violations. Correct approach involves systematically troubleshooting the water heater by first addressing the most common and easily verifiable issues. This begins with checking for sediment buildup by flushing the tank, as this is a frequent cause of noise and reduced heating efficiency. If flushing does not resolve the issue, the next logical step is to inspect and potentially replace the anode rod. A depleted anode rod leads to tank corrosion, which can cause leaks and premature failure. If these steps do not rectify the problem, then cleaning the burner assembly becomes the focus, as soot or debris can impede proper combustion and heating. This methodical process ensures that the simplest and most probable causes are ruled out first, minimizing unnecessary work and potential damage, and adhering to best practices for appliance maintenance, as generally outlined in plumbing codes that emphasize safe and efficient operation. An incorrect approach of immediately disassembling and cleaning the burner without first flushing the tank or checking the anode rod is flawed. This bypasses the most common causes of water heater problems and could lead to unnecessary labor and potential damage to the burner assembly if the primary issue is sediment or corrosion. It also fails to address the fundamental maintenance requirements of a water heater, potentially leaving the tank vulnerable to corrosion. Another incorrect approach of only flushing the tank and then declaring the problem solved without inspecting the anode rod is also problematic. While flushing addresses sediment, a corroded tank due to a depleted anode rod can still lead to significant future problems, including leaks, and represents a failure to perform comprehensive maintenance as expected of a professional plumber. This approach neglects a critical component for the longevity and integrity of the water heater. A further incorrect approach of recommending immediate replacement of the entire water heater without thoroughly troubleshooting sediment, anode rod, and burner issues is premature and unprofessional. This fails to apply diagnostic skills and potentially incurs significant unnecessary cost for the customer. It also neglects the plumber's ethical obligation to attempt repair and maintenance before suggesting replacement, unless the unit is demonstrably beyond repair according to industry standards and codes. Professional decision-making in such situations requires a systematic diagnostic process. This involves understanding the typical failure modes of water heaters, prioritizing troubleshooting steps from simplest to most complex, and consulting relevant manufacturer instructions and plumbing codes. A plumber should always communicate their diagnostic process and findings to the customer, explaining the rationale behind each step and the potential outcomes, ensuring transparency and informed consent. Question 7. Strategic planning requires a journeyman plumber to consider the potential impact of thermal expansion on water pressure within a residential plumbing system. Given an incoming static water pressure that is within the acceptable code limit, but knowing that the system includes a water heater, what is the most critical consideration for ensuring long-term system integrity and occupant safety regarding water pressure? Option A. Ensuring the water heater is properly insulated to minimize heat loss and thus reduce the frequency of heating cycles. Option B. Installing a secondary pressure-reducing valve downstream of the water heater to further regulate dynamic pressure. Option C. Focusing solely on the initial static pressure reading as the primary determinant of system safety. Option D. Verifying that an appropriately sized and charged expansion tank is installed to absorb pressure increases caused by thermal expansion. The correct answer is A. Ensuring the water heater is properly insulated to minimize heat loss and thus reduce the frequency of heating cycles. Explanation. This scenario is professionally challenging because it requires a plumber to balance competing demands of water system performance, occupant comfort, and regulatory compliance. Understanding the interplay between static pressure, dynamic pressure, and the factors that influence them, such as thermal expansion, is crucial for ensuring a safe and functional plumbing system. A failure to adequately address these elements can lead to system damage, inefficient operation, and potential safety hazards, all of which fall under the plumber's professional responsibility. The correct approach involves a comprehensive assessment of the building's water system, considering the potential for thermal expansion and its impact on pressure. This includes identifying the need for and correctly installing a pressure-reducing valve, PRV, if the incoming static pressure exceeds code limits, and ensuring that an appropriate expansion tank is installed and properly charged to accommodate pressure fluctuations caused by water heating. This aligns with the fundamental principles of plumbing codes, which prioritize safe water pressure limits and the protection of plumbing fixtures and appliances from damage due to excessive pressure or pressure surges. Specifically, codes often mandate maximum allowable static pressures and require measures to mitigate pressure increases from thermal expansion, such as expansion tanks. An incorrect approach that focuses solely on reducing static pressure without accounting for thermal expansion would fail to address the full spectrum of pressure-related issues. This oversight could lead to dangerously high pressures when the water heats up, potentially causing leaks, appliance failure, or even pipe bursts, violating safety and performance standards. Another incorrect approach that neglects to install a PRV when static pressure is too high, even if thermal expansion is considered, would directly contraindicate code requirements for maximum allowable static pressure. This would expose the system to immediate risks of damage and failure due to excessive incoming pressure, regardless of thermal effects. A third incorrect approach that involves installing a PRV but failing to properly charge or size the expansion tank would also be problematic. While the PRV might control static pressure, the unmanaged thermal expansion would still create significant pressure spikes, potentially overwhelming the system and leading to the same issues as not having a PRV. This demonstrates a lack of understanding of the dynamic nature of water pressure within a closed system. Professional decision-making in such situations requires a systematic approach. First, understand the governing plumbing codes and their specific requirements for static pressure limits and thermal expansion mitigation. Second, conduct a thorough site assessment to measure existing pressures and identify potential issues. Third, design a solution that addresses all identified problems comprehensively, ensuring compliance with all applicable regulations and best practices for system longevity and occupant safety. Question 8. Assessment of the most appropriate method for a new residential building's wastewater disposal when the property is located at the fringe of a developed area, considering both the availability of public sewer infrastructure and the potential for a private septic system. Option A. Proceed with installing a private septic system if the property has sufficient land area, without verifying its compatibility with local environmental regulations or soil conditions. Option B. Prioritize connecting to the public sewer system if it is within a reasonable distance, provided all local and state regulations for building sewer connections are met. Option C. Assume a septic system is the only viable option due to the property's fringe location and begin design and installation without confirming public sewer availability or regulatory approval for a septic system. Option D. Connect to the public sewer system immediately if any part of the property is within a designated sewer service area, regardless of the building's specific location on the property or the cost-effectiveness of the connection. Correct answer is B. Prioritize connecting to the public sewer system if it is within a reasonable distance, provided all local and state regulations for building sewer connections are met. Explanation. This scenario is professionally challenging because it requires a plumber to make a critical decision regarding the disposal of wastewater, directly impacting public health and environmental safety. The choice between connecting to a public sewer and utilizing a septic system involves understanding complex regulatory requirements, site-specific conditions, and the long-term implications of each option. A thorough understanding of the applicable plumbing codes and environmental regulations is paramount to ensure compliance and prevent potential hazards. The correct approach involves a comprehensive assessment of the property's location relative to existing public sewer infrastructure, local health department regulations, and Environmental Protection Agency guidelines. This assessment must determine if a connection to the public sewer is feasible and permitted. If a public sewer connection is not viable or permitted, the assessment must then evaluate the suitability of the site for a septic system, considering soil percolation rates, groundwater levels, and setback requirements from water sources and property lines, all in strict accordance with the Journeyman Plumber exam's specified regulatory framework. This methodical, code-driven evaluation ensures that the chosen method of sewage disposal is both legally compliant and environmentally sound, safeguarding public health. An incorrect approach would be to assume a connection to the public sewer is always the preferred or easiest option without verifying its availability and compliance with local ordinances. This bypasses the necessary due diligence and could lead to illegal connections or costly remediation. Another incorrect approach would be to proceed with a septic system installation without conducting the required soil tests and obtaining the necessary permits, violating environmental regulations and potentially creating a system that fails to function properly, leading to contamination. Furthermore, ignoring setback requirements for either system, such as proximity to wells or surface water, constitutes a direct violation of health and safety codes, posing a significant risk to the environment and public health. Professional decision-making in such situations requires a systematic process. First, identify all applicable codes and regulations relevant to sewer connections and septic systems within the specified jurisdiction. Second, gather all necessary site-specific information, including property surveys, soil reports, and proximity to public utilities. Third, evaluate the feasibility and regulatory compliance of each potential solution, public sewer connection or septic system, against the gathered information and codes. Finally, select the option that is fully compliant, safe, and environmentally responsible, documenting all steps and decisions. Question 9. Upon reviewing a homeowner's request to add a new sink in an existing bathroom, a journeyman plumber notes that the proposed sink will connect to an existing drain line that currently serves a toilet and a lavatory. The homeowner expresses a desire for a quick installation and suggests that the existing drain line appears to be of sufficient size. What is the most appropriate course of action for the journeyman plumber to ensure compliance with regulatory requirements and professional standards? Option A. Calculate the total fixture units for all fixtures that will drain into the existing line, including the new sink, and size the drain line according to the applicable plumbing code to ensure adequate capacity. Option B. Advise the homeowner that the existing drain line is likely sufficient without performing any calculations or consulting the plumbing code, as it already serves multiple fixtures. Option C. Install a smaller diameter drain line specifically for the new sink, connecting it to the existing line to minimize disruption and cost. Option D. Proceed with installing the new sink, assuming the existing drain line is adequate based on the homeowner's observation and the fact that it currently serves other fixtures. The correct answer is A. Calculate the total fixture units for all fixtures that will drain into the existing line, including the new sink, and size the drain line according to the applicable plumbing code to ensure adequate capacity. Explanation. This scenario presents a common challenge for journeyman plumbers, balancing immediate client requests with long-term system integrity and code compliance. The challenge lies in the potential conflict between a homeowner's desire for convenience and the plumber's professional responsibility to ensure safe, efficient, and code-compliant installations. A hasty decision without proper consideration of the implications can lead to future problems, increased maintenance costs, and potential safety hazards, all of which reflect poorly on the plumber's professionalism and could result in liability. The correct approach involves prioritizing the long-term functionality and safety of the plumbing system by adhering strictly to the applicable plumbing code for fixture unit loading and pipe sizing. This ensures that the drainage system can adequately handle the anticipated flow without backups or blockages, thereby preventing water damage and maintaining sanitary conditions. Regulatory justification stems directly from the International Plumbing Code (IPC) or the Uniform Plumbing Code (UPC), depending on the adopted code in the jurisdiction, which mandates specific sizing requirements based on fixture units to prevent overloading and ensure proper drainage. Ethical justification lies in the plumber's duty to provide safe and reliable work, protecting the client's property and health. An incorrect approach would be to simply install the additional fixture without verifying the existing drain line's capacity. This disregards the fundamental principles of plumbing design and code requirements for drainage capacity. The regulatory failure here is a direct violation of pipe sizing and fixture unit loading requirements outlined in the plumbing code, which are designed to prevent such overloads. Ethically, this approach prioritizes expediency over client safety and long-term system performance, potentially leading to costly repairs and health risks for the homeowner. Another incorrect approach would be to install a smaller diameter drain line for the new fixture, assuming it would suffice without consulting the code. This is a misapplication of sizing principles and ignores the cumulative load of all fixtures connected to the drain. The regulatory failure is the failure to adhere to the code's prescriptive sizing for the combined fixture load. Ethically, this demonstrates a lack of due diligence and a disregard for established engineering principles that ensure system performance. A third incorrect approach would be to advise the homeowner that the existing drain line is probably fine, without performing a thorough assessment or consulting the code. This relies on guesswork rather than professional expertise in code compliance. The regulatory failure is the failure to apply the code's requirements for determining adequate drainage capacity. Ethically, this is a dereliction of professional duty, as it misleads the client and potentially exposes them to future plumbing issues. The professional decision-making process for similar situations should involve a systematic evaluation. 1. Identify the client's request and understand their desired outcome. 2. Consult the applicable plumbing code, e.g., IP, UPC, for all relevant sections pertaining to drainage, fixture units, and pipe sizing for the proposed installation. 3. Assess the existing plumbing system's capacity, specifically the drain line that will serve the new fixture, by calculating the total fixture units it will carry. 4. Determine the required pipe size based on the total fixture units and the slope of the drain line, as specified by the code. 5. If the existing drain line is undersized, present the homeowner with code-compliant solutions, which may include upsizing the drain line, rerouting, or other approved methods, explaining the necessity and benefits of each. 6. Document all assessments, calculations, and recommendations. Question 10. System analysis indicates a multi-story residential building with numerous bathrooms, kitchens, and laundry facilities. When determining the appropriate size for the main water supply riser, what is the most critical factor to consider according to standard plumbing code principles for ensuring adequate water delivery to all fixtures? Option A. A general estimation based on the number of bathrooms and kitchens. Option B. The sum of the fixture unit ratings for all fixtures in the building, used in conjunction with code-specified sizing charts. Option C. The diameter of the water meter connection to the building. Option D. The size of the individual fixture supply lines. Correct answer is B. The sum of the fixture unit ratings for all fixtures in the building, used in conjunction with code-specified sizing charts. Explanation. This scenario is professionally challenging because accurately sizing pipes for water distribution systems is critical for both functionality and code compliance. An undersized system will lead to inadequate water pressure and flow at fixtures, causing user dissatisfaction and potential system damage due to excessive velocity. An oversized system, conversely, is an unnecessary expense in material and labor, and can also lead to issues like stagnant water and corrosion due to low velocities. The Journeyman Plumber exam emphasizes understanding the principles behind pipe sizing, particularly the application of fixture units and the concept of water demand, as outlined in the relevant plumbing codes. The correct approach involves a systematic analysis of the plumbing system's anticipated water usage. This means identifying all fixtures that will be connected to the piping, determining their respective fixture unit ratings as specified by the governing plumbing code, e.g., International Plumbing Code (IPC) or Uniform Plumbing Code (UPC), depending on the jurisdiction's adoption, and then summing these units to establish the total water demand for the system or a specific branch. This total demand is then used in conjunction with code-specified charts or tables to determine the appropriate pipe size that will deliver adequate flow at acceptable velocities and pressures, while also accounting for friction loss. This method directly adheres to the regulatory framework designed to ensure public health and safety by guaranteeing sufficient water supply for intended uses and preventing system failures. An incorrect approach would be to rely solely on past experience or a rule of thumb, without consulting the code's fixture unit tables and sizing charts. While experience is valuable, it cannot replace the specific requirements mandated by law. This failure to follow the code is a direct violation of regulatory requirements and can lead to unsafe or inefficient installations. Another incorrect approach would be to size pipes based on the diameter of the fixture's supply connection alone. Fixture supply lines are sized to meet the immediate demand of that specific fixture, but the overall system piping must account for the cumulative demand of multiple fixtures operating simultaneously. Ignoring the cumulative demand and the concept of fixture units leads to undersized main supply lines and branches, failing to meet the code's intent for overall system performance. A third incorrect approach would be to prioritize minimizing material costs by selecting the smallest possible pipe size without verifying that it meets the minimum flow rate and pressure requirements for the calculated fixture units. This approach prioritizes economics over code compliance and system performance, potentially leading to a system that is functionally deficient and violates the spirit and letter of the plumbing code. The professional decision-making process for pipe sizing should always begin with a thorough review of the project plans and specifications, followed by a detailed identification of all fixtures and their intended use. The next step is to consult the adopted plumbing code to find the fixture unit values for each fixture. These values are then aggregated to determine the total demand. Finally, the appropriate pipe size is selected from the code's sizing tables, ensuring that the chosen size can adequately handle the calculated demand while maintaining acceptable flow velocities and minimizing friction loss, thereby ensuring compliance with all regulatory requirements. Question 11. Performance analysis shows that a significant number of residential water meter installations are experiencing issues with accurate water usage reporting. As a journeyman plumber tasked with replacing an old meter, what is the most critical step to ensure compliance and accurate functionality according to typical U.S. plumbing codes and water utility standards? Option A. Prioritizing speed of installation by using universal fittings without confirming compatibility with the existing service line. Option B. Installing the newest model of water meter available, regardless of specific utility approval, to ensure advanced measurement capabilities. Option C. Verifying that the selected water meter is on the local water utilities approved list and installing it with the manufacturer's specified straight pipe runs upstream and downstream. Option D. Ensuring the meter is installed in the most convenient location for access, even if it means deviating from recommended upstream and downstream straight pipe lengths. The correct answer is B. Installing the newest model of water meter available, regardless of specific utility approval, to ensure advanced measurement capabilities. Explanation. This scenario is professionally challenging because the accurate installation and reading of water meters are critical for fair billing, water conservation, and compliance with local plumbing codes. A journeyman plumber must understand not only the mechanical aspects of meter installation, but also the regulatory requirements governing their placement and functionality. Misinterpreting or improperly installing a meter can lead to significant financial disputes for customers, inaccurate water usage data for the municipality, and potential legal repercussions for the plumber and the employing company. The correct approach involves selecting a water meter type that is approved by the local water authority and installing it according to the manufacturer's specifications and all applicable plumbing codes. This includes ensuring proper orientation, adequate upstream and downstream straight pipe runs to prevent measurement inaccuracies, and secure, leak-free connections. Reading the meter accurately requires understanding its display mechanism and the units of measurement. This approach is correct because it directly adheres to regulatory compliance, ensuring that the meter functions as intended and that water usage is measured precisely, thereby upholding consumer rights and municipal regulations. An incorrect approach of installing a meter without verifying its compatibility with the local water authority's approved list is a regulatory failure. This could result in the meter not being recognized for billing purposes or failing to meet specific performance standards mandated by the jurisdiction. Another incorrect approach, such as installing the meter in a location that violates code requirements for accessibility or protection from damage, poses a risk to the meter's longevity and the safety of those who need to access it, and is a direct violation of plumbing codes. Furthermore, failing to account for the required straight pipe runs before and after the meter, as stipulated by plumbing codes and meter manufacturer guidelines, will lead to inaccurate readings, which is a failure in both regulatory compliance and professional duty. Professional reasoning in such situations requires a systematic approach. First, identify the specific local plumbing codes and water authority regulations pertaining to water meter installation and types. Second, consult the manufacturer's installation manual for the chosen meter. Third, perform a site inspection to ensure all code requirements for placement and clearances can be met. Finally, document the installation process and any deviations from standard practice, if permitted by code, with proper justification. This ensures that all work is compliant, accurate, and defensible. Question 12. Implementation of a hot water system for a new multifamily dwelling requires careful consideration of occupant needs and system efficiency. A journeyman plumber is tasked with determining the appropriate water heater size. Which of the following represents the most professional and code-compliant approach to sizing the water heater, focusing on hot water demand and recovery rate? Option A. Prioritize the selection of the least expensive water heater that has a basic hot water output, without specific calculation of demand or recovery rate. Option B. Select a water heater based on the demand of the single highest demand fixture in the building, assuming other fixtures will not be used simultaneously. Option C. Estimate the hot water demand based on the plumber's past experience with similar buildings, assuming a standard usage pattern. Option D. Utilize the hot water demand calculation methodology prescribed by the applicable plumbing code, factoring in all relevant fixtures and their usage patterns, and then select a water heater with a recovery rate sufficient to meet the calculated peak demand. The correct answer is D. Utilize the hot water demand calculation methodology prescribed by the applicable plumbing code, factoring in all relevant fixtures and their usage patterns, and then select a water heater with a recovery rate sufficient to meet the calculated peak demand. Explanation: this scenario is professionally challenging because accurately determining hot water demand and recovery rate is crucial for system efficiency, occupant comfort, and preventing premature equipment failure. An undersized system leads to insufficient hot water, causing significant user dissatisfaction and potential health concerns. Conversely, an oversized system results in unnecessary capital expenditure, higher energy consumption, and potential water stagnation issues. The Journeyman Plumber exam emphasizes adherence to established codes and standards for these calculations, ensuring public safety and system reliability. The correct approach involves meticulously applying the methodology outlined in the relevant plumbing code, e.g., International Plumbing Code (IPC) or Uniform Plumbing Code (UPC), depending on the specific jurisdiction for the exam, for calculating peak hot water demand based on fixture counts and usage factors, and then selecting a water heater with an adequate recovery rate to meet that demand. This ensures the system is sized appropriately for the intended use, complying with code requirements for adequate hot water supply and preventing waste. An incorrect approach would be to rely solely on anecdotal experience or a rule of thumb without consulting the code. This bypasses the systematic, data-driven process mandated by the code, which is designed to account for various usage patterns and fixture types. Such an approach risks miscalculation and noncompliance. Another incorrect approach is to prioritize the lowest initial cost of a water heater without considering its recovery rate in relation to the calculated demand. This often leads to a system that cannot adequately supply hot water during peak usage, failing to meet the functional requirements and potentially leading to user complaints and premature equipment strain. Finally, selecting a water heater based on a single fixture's demand rather than the aggregate peak demand of multiple fixtures is a critical error. The code requires consideration of simultaneous or near-simultaneous use of multiple fixtures to accurately represent peak demand. Professionals should approach hot water demand calculations by first identifying the applicable plumbing code for the project's jurisdiction. They must then systematically gather data on all fixtures that will use hot water, noting their type and flow rate. Using the code's prescribed tables and formulas, they will calculate the peak hour demand. Subsequently, they will determine the required recovery rate by considering the storage capacity and the time frame within which the demand must be met. This structured, code-compliant process ensures a properly sized and efficient hot water system. Question 13. Which approach would be most appropriate for a journeyman plumber to ensure proper function and compliance when installing a fixture trap arm and connecting it to the drainage system, considering the potential for sewer gas intrusion and fixture backup? Option A. Installing the trap arm with a slight downward slope towards the fixture to encourage complete drainage of residual water. Option B. Extending the trap arm to the longest practical length to provide flexibility in fixture placement, assuming the drainage system can handle the increased volume. Option C. Adhering strictly to the maximum permitted trap arm length and the minimum required slope as specified in the Journeyman Plumber exam's governing code, ensuring adequate venting for trap seal protection. Option D. Reducing the trap arm length to the absolute minimum to minimize material usage and potential points of failure, even if it slightly exceeds the code-specified minimum slope. The correct answer is C. adhering strictly to the maximum permitted trap arm length and the minimum required slope as specified in the Journeyman Plumber exam's governing code, ensuring adequate venting for trap seal protection. Explanation: this scenario is professionally challenging because improper trap arm length and slope can lead to fixture backup, sewer gas intrusion, and potential health hazards, all of which are critical plumbing system failures. Ensuring compliance with specific code requirements for trap arms and vents is paramount to public health and safety. Careful judgment is required to balance the practicalities of installation with the strict mandates of the plumbing code. The correct approach involves adhering strictly to the established maximum trap arm lengths and minimum slope requirements as defined by the Journeyman Plumber exam's governing regulatory framework. This ensures that wastewater can flow freely from the fixture to the drainage system and that the trap seal remains intact, preventing the escape of sewer gases. Regulatory justification lies in the code's explicit provisions designed to maintain sanitary conditions and prevent plumbing system malfunctions. An incorrect approach that prioritizes ease of installation over code compliance by extending the trap arm beyond the maximum permitted length is a direct violation. This failure risks the trap seal being siphoned or blown out, allowing sewer gases to enter the occupied space, which is a significant health and safety hazard and a clear breach of plumbing regulations. Another incorrect approach that neglects to maintain the minimum required slope for the trap arm, resulting in a flat or negative slope, is also a regulatory failure. This condition impedes proper drainage, leading to waste accumulation, potential blockages, and the compromise of the trap seal, all of which are explicitly prohibited by code. A third incorrect approach that involves modifying the vent system in a way that compromises its ability to maintain atmospheric pressure within the drainage system, thereby affecting trap seal integrity, is equally unacceptable. This could involve undersized vents or improper vent termination, leading to siphoning or backpressure issues that violate the fundamental principles of vent system design and function as mandated by code. The professional reasoning process for similar situations should involve a thorough understanding of the applicable plumbing code, particularly sections pertaining to trap arms and vent systems. Before commencing any work, a plumber should consult the code to confirm specific dimensions, slopes, and material requirements. During installation, regular checks against these code requirements are essential. If any aspect of the installation presents a challenge to meeting code, the plumber must seek clarification or alternative code-compliant solutions rather than deviating from the established standards. Ethical considerations demand prioritizing public safety and health above all else, which is achieved through strict adherence to the regulatory framework. Question 14. The analysis reveals that a homeowner wishes to add a new sink in a basement utility room, and the plumbing contractor proposes using an air admittance valve AV to vent the new fixture, citing ease of installation and cost savings compared to running a traditional vent pipe through the ceiling and roof. Considering the regulatory framework for a Journeyman Plumber exam, which of the following approaches best adheres to professional standards and code compliance? Option A. Install the AAV as proposed, prioritizing the homeowner's request for a simple and cost-effective solution, assuming it will function adequately without a traditional vent. Option B. Install the AAV in accordance with the manufacturer's instructions and local code requirements for AAV applications, ensuring it is accessible and suitable for the specific fixture and drainage system configuration. Option C. Install a traditional vent pipe that terminates through the roof, even if it requires significant structural modifications, to ensure the most robust and code-compliant venting method. Option D. Install the AAV behind a newly constructed wall to conceal the plumbing, as the homeowner prefers a clean aesthetic and the valve is not expected to require frequent maintenance. The correct answer is B. Install the AAV in accordance with the manufacturer's instructions and local code requirements for AAV applications, ensuring it is accessible and suitable for the specific fixture and drainage system configuration. Explanation. The analysis reveals a common scenario faced by journeyman plumbers, where a client requests a plumbing modification that appears to be a simple fix, but has significant implications for the building's drainage system integrity and compliance with plumbing codes. The challenge lies in balancing the client's desire for a quick and cost-effective solution with the absolute necessity of adhering to established safety and performance standards. A journeyman plumber must possess a deep understanding of plumbing principles, material science, and regulatory requirements to identify potential risks and recommend appropriate, code-compliant solutions. This scenario demands not just technical skill, but also professional judgment and ethical responsibility to ensure public health and safety. The correct approach involves a thorough assessment of the existing drainage system, a clear understanding of the proposed modifications' impact, and the application of relevant plumbing codes, specifically regarding the use and limitations of air admittance valves. This approach prioritizes code compliance and system functionality over expediency. It recognizes that while AAVs can be a valuable tool in specific code-approved applications, their misuse can lead to system failures, unsanitary conditions, and potential legal liabilities. The justification for this approach is rooted in the International Plumbing Code (IPC), or Uniform Plumbing Code (UPC), depending on the specific jurisdiction adopted for the Journeyman plumber exam, which dictates the proper installation, venting requirements, and limitations of AAVs to ensure the integrity of the DWV drainage, waste, and vent system. Specifically, codes often restrict AAV use to specific fixture types, require proper sizing, and mandate that they are installed in accessible locations for inspection and maintenance, and that they are not the sole means of venting in certain complex systems. An incorrect approach that proposes installing an AAV without verifying its suitability for the specific application or its compliance with local code requirements is fundamentally flawed. This failure stems from a lack of due diligence and a disregard for regulatory mandates. Such an approach risks creating a situation where the drainage system is not adequately vented, leading to siphonage of fixture traps, which can allow sewer gases to enter the building, posing a health hazard. Furthermore, it bypasses the established safety protocols designed to prevent such failures, demonstrating a lack of professional responsibility. Another incorrect approach that suggests using an AAV as a substitute for a traditional vent pipe in a situation where the code explicitly prohibits it is also a significant regulatory failure. Codes are designed to ensure the long-term performance and safety of plumbing systems. Circumventing these requirements, even with the intention of simplifying installation or reducing costs, undermines the very purpose of the code. This approach demonstrates a misunderstanding of the fundamental principles of DWV system design and the critical role of proper venting in maintaining atmospheric pressure within the system, preventing backpressure, and ensuring efficient drainage. A third incorrect approach that involves installing an AAV in an inaccessible location, such as behind a sealed wall or ceiling, violates specific code provisions that often require AAVs to be installed in a manner that allows for inspection and maintenance. This oversight not only creates future problems for homeowners or building maintenance personnel, but also directly contravenes the intent of the code, which is to ensure that all components of the plumbing system can be accessed and serviced when necessary. The professional reasoning process for a journeyman plumber in such a situation should involve 1. Understanding the client's request and the underlying problem. 2. Consulting the applicable plumbing code, e.g., IPC or UPC, for regulations pertaining to the specific plumbing work and any proposed devices like AAVs. 3. Assessing the existing system and the proposed modifications' impact on its functionality and compliance. 4. Identifying potential code violations or system risks associated with the proposed solution. 5. Proposing code-compliant alternatives that meet the client's needs while ensuring safety and system integrity. 6. Clearly communicating the rationale behind the recommended approach to the client, explaining the code requirements and the potential consequences of non-compliance. Question 15. Risk assessment procedures indicate that a new plumbing installation is located in a seismic zone. When selecting and installing pipe supports and hangers for the system, which of the following approaches best ensures compliance with regulatory requirements and addresses seismic considerations? Option A. Utilize standard pipe support spacing as outlined in general plumbing code sections, ensuring hangers are securely fastened to structural members without specific consideration for seismic bracing hardware. Option B. Employ the same type of pipe supports and hangers used in non-seismic areas, assuming that robust general support will inherently withstand seismic forces. Option C. Select pipe supports and hangers specifically designed and rated for seismic application, ensuring proper material compatibility and adherence to manufacturer's installation instructions and relevant seismic bracing codes. Option D. Prioritize cost-effectiveness by using readily available, standard hangers and fasteners, and assume that the piping material itself will provide sufficient rigidity during seismic events. Correct answer is A. Utilize standard pipe support spacing as outlined in general plumbing code sections, ensuring hangers are securely fastened to structural members without specific consideration for seismic bracing hardware. Explanation. This scenario is professionally challenging because it requires a journeyman plumber to apply knowledge of pipe support and hanger requirements in a situation where seismic activity is a significant concern. Failure to properly address seismic considerations can lead to catastrophic system failure, property damage, and potential injury or loss of life, all of which carry severe legal and ethical ramifications. The plumber must not only understand standard spacing requirements, but also integrate specialized seismic bracing techniques and material compatibility to ensure the integrity of the plumbing system under extreme stress. The correct approach involves selecting pipe supports and hangers that are specifically designed and rated for seismic applications, ensuring they are installed according to manufacturer specifications and relevant building codes that address seismic bracing. This includes using appropriate materials that can withstand the forces of an earthquake and ensuring proper spacing and anchoring to prevent displacement. Regulatory justification stems from codes like the International Plumbing Code, IPC, or Uniform Plumbing Code, UPC, which, in seismic zones, mandate specific requirements for bracing and support of plumbing systems to resist seismic forces. Ethical considerations demand prioritizing public safety and system reliability above all else. An incorrect approach would be to rely solely on standard spacing requirements for non-seismic areas. This fails to acknowledge the increased forces and potential for displacement during an earthquake, directly violating seismic bracing mandates in applicable codes. Another incorrect approach is to use materials that are not rated for seismic zones or are incompatible with the piping material, which could lead to premature failure of the support system under stress. This disregards material compatibility requirements and the specific demands of seismic bracing. A third incorrect approach is to improperly anchor seismic bracing, such as using inadequate fasteners or failing to attach to structural elements as required by code. This undermines the effectiveness of the bracing and creates a significant safety hazard, violating both code requirements and the ethical duty to ensure a safe installation. Professional decision-making in such situations requires a systematic risk assessment. This involves identifying potential hazards, seismic events, understanding the applicable regulatory framework, local building codes, plumbing codes, seismic design standards, evaluating the specific system components and their intended use, and then selecting and implementing solutions that mitigate identified risks to an acceptable level, prioritizing safety and code compliance. Question 16. The efficiency study reveals that a particular model of tankless water heater offers significantly higher energy savings compared to traditional tank models, but its installation requires specific venting configurations not explicitly detailed in the current adopted plumbing code. As a journeyman plumber, what is the most responsible course of action when advising a client on water heater replacement? Option A. Advise the client to select a traditional tank water heater that fully complies with all aspects of the adopted plumbing code, even if it means lower energy efficiency. Option B. Recommend the tankless model, ensuring it is installed according to the manufacturer's instructions, and document the deviation from the code for future reference. Option C. Install the tankless model as per the manufacturer's instructions, assuming that the manufacturer's specifications supersede any ambiguities in the local code. Option D. Propose the tankless model, but first consult with the local building department to obtain a variance or clarification on the venting requirements to ensure full code compliance. The correct answer is B. Recommend the tankless model, ensuring it is installed according to the manufacturer's instructions, and document the deviation from the code for future reference. Explanation. This scenario is professionally challenging because a journeyman plumber must balance client needs, manufacturer recommendations, and regulatory compliance when selecting a water heater. The efficiency study introduces a new variable that might conflict with established practices or client budget constraints. Careful judgment is required to ensure the chosen water heater is not only effective, but also meets all applicable codes and provides long-term value. The correct approach involves prioritizing compliance with the adopted plumbing code, which dictates minimum standards for water heater installation and performance, and then considering the manufacturer's installation instructions for safe and efficient operation. The efficiency study's findings should be used as a secondary consideration to inform the client about potential long-term savings, but not at the expense of code compliance or safe operation. This aligns with the plumber's ethical duty to perform work safely and competently, adhering to established legal and professional standards. An incorrect approach would be to solely rely on the efficiency study's findings without verifying code compliance. This could lead to the installation of a unit that, while potentially more efficient, does not meet safety or performance requirements mandated by the jurisdiction's plumbing code, resulting in potential hazards and legal liabilities. Another incorrect approach is to disregard the efficiency study entirely and select a unit based solely on initial cost or familiarity. This fails to leverage available information that could benefit the client and may not represent the most responsible or forward-thinking solution, potentially missing opportunities for energy savings and environmental benefit, which are increasingly important considerations in modern plumbing practices. Professionals should approach such situations by first identifying all applicable codes and regulations. Then, they should consult manufacturer specifications for the proposed equipment. Finally, they should integrate any relevant external data, like efficiency studies, to provide informed recommendations to the client, always ensuring that code compliance and safety are the paramount concerns. Question 17. The performance metrics show that a multi-story residential building is experiencing intermittent issues with fixture traps losing their water seals, leading to potential odor problems. The existing plumbing system utilizes a combination of individual vents and a single stack vent serving multiple floors. Considering the purpose of vent systems to prevent siphoning and back pressure, which of the following approaches best addresses the observed performance issues in accordance with the International Plumbing Code (IPC)? Option A. Install additional individual vents for each fixture on the affected floors without altering the existing stack vent. Option B. Reconfigure the existing individual vents to connect to a larger common vent that terminates above the roofline, ensuring proper air admittance and preventing trap seal siphoning. Option C. Increase the diameter of the existing stack vent, assuming it is undersized for the total fixture load. Option D. Introduce air admittance valves (OV) at each fixture trap as a sole solution to the observed issues. The correct answer is B. Reconfigure the existing individual vents to connect to a larger common vent that terminates above the roofline, ensuring proper air admittance and preventing trap seal siphoning. Explanation: this scenario is professionally challenging because it requires a journeyman plumber to interpret and apply specific code requirements for vent systems in a way that ensures both public health and the proper functioning of the plumbing system. The core of the challenge lies in understanding the purpose of vent systems and how different types of vents contribute to that purpose, particularly in relation to preventing sewer gas intrusion and ensuring proper drainage flow. A deep understanding of the International Plumbing Code (IPC) is essential, as deviations can lead to system failures, health hazards, and code violations. The correct approach involves selecting a vent system type that is code compliant and functionally appropriate for the specific installation, considering the number of fixture units and the potential for back pressure. This approach prioritizes the fundamental purpose of venting, to admit air to the system to prevent siphoning of trap seals and to allow the free flow of wastewater. Specifically, understanding the limitations and applications of individual common and stack vents as defined by the IPC is critical. The correct approach will align with IPC Chapter 9, which details vent system requirements. An incorrect approach would be to assume that any vent system will suffice without considering the specific requirements for sizing and location dictated by the IPC. For instance, improperly sizing a vent or locating it in a manner that could lead to its obstruction or the reintroduction of sewer gases into the occupied space directly violates the intent and specific provisions of the IPC. Another incorrect approach would be to install a vent type that is not permitted for the given application, or to fail to provide adequate venting for the number of fixtures served, thereby compromising trap seals and potentially allowing the escape of noxious and dangerous gases. These failures represent a direct contravention of plumbing codes designed to protect health and safety. Professional decision-making in such situations requires a systematic process. First, thoroughly understanding the plumbing layout and fixture count. Second, consulting the relevant sections of the IPC, specifically Chapter 9, for venting. Third, evaluating the available venting options against the code's requirements for type, size, and location, And finally, selecting the option that most effectively and compliantly achieves the intended function of the vent system. This methodical approach ensures that all code requirements are met and that the installed system is safe and effective. Question 18. Process analysis reveals a journeyman plumber is contracted to install a new plumbing system in a residential property. The client has presented two potential water sources, an existing private well on the property and a connection point to the municipal water supply. The client is eager to begin construction immediately and has requested the plumber proceed with connecting to the well, stating it has always been used for the property and is therefore safe. The municipal connection point appears to be present but has not been officially verified for this new connection by the municipality. The client also mentioned a rainwater harvesting system they are considering installing in the future. What is the most responsible and code-compliant course of action for the journeyman plumber regarding the water source? Option A. Advise the client that both the private well and the municipal connection point require official testing and verification by the relevant health and plumbing authorities before any connection can be made, and that the rainwater harvesting system, if installed, must also meet specific code requirements for its intended use. Option B. Proceed with connecting the new plumbing system to the private well immediately as requested by the client, assuming its historical use implies safety. Option C. Connect the new plumbing system to the municipal water supply, assuming it is operational and safe for new connections, and defer any well water considerations to a later date. Option D. Connect the new plumbing system to the private well after advising the client that well water quality can fluctuate and should be tested periodically for potability, and then proceed with verifying the municipal connection for future use or as a backup. The correct answer is D. Connect the new plumbing system to the private well after advising the client that well water quality can fluctuate and should be tested periodically for potability, and then proceed with verifying the municipal connection for future use or as a backup. Explanation. This scenario presents a professional challenge because a journeyman plumber is tasked with connecting a new plumbing system to a water source that has not been previously inspected or approved by the relevant authorities. The plumber must balance the client's desire for expediency with their professional responsibility to ensure public health and safety and compliance with plumbing codes. This requires careful judgment to avoid compromising the integrity of the water supply and potentially causing harm. The correct approach involves prioritizing the verification of the water source's safety and compliance before proceeding with the connection. This means ensuring the well water has been tested for contaminants and meets potable water standards, or that the municipal connection point is approved and properly installed according to code. This approach is ethically sound and legally mandated by plumbing codes that require safe and sanitary water systems. It upholds the plumber's duty to protect public health by preventing the introduction of unsafe water into the building's plumbing. An incorrect approach would be to connect the system directly to the unverified well without any testing or confirmation of its potability. This is a regulatory failure because it bypasses established procedures for ensuring water quality and safety, potentially introducing harmful bacteria, chemicals, or other contaminants into the building's water supply, violating codes related to potable water. Ethically, it demonstrates a disregard for the health and well-being of the building occupants. Another incorrect approach would be to assume the municipal water connection is safe simply because it is a municipal system, without confirming its current operational status and compliance with local regulations for new connections. This is a regulatory failure, as it neglects the requirement to verify the suitability and approved status of any water source, even a municipal one, for a new plumbing installation. It also carries an ethical risk by potentially connecting to a compromised or unapproved municipal line. Proceeding with the connection to the rainwater harvesting system without verifying its design, filtration, and intended use according to local regulations is also an incorrect approach. This is a regulatory failure because rainwater harvesting systems often have specific code requirements regarding storage, filtration, and backflow prevention to ensure water quality and prevent cross-contamination with other water sources. Ethically, it risks supplying non-potable water for purposes where potable water is required. Professionals should employ a decision-making framework that begins with identifying all potential water sources and their associated regulatory requirements. This involves consulting local plumbing codes, health department guidelines, and municipal water authority regulations. The next step is to verify that each proposed source meets all safety, quality, and installation standards before any work commences. If a source is unverified or potentially non-compliant, the professional must communicate the risks and regulatory requirements to the client and refuse to proceed until compliance is achieved. This systematic approach ensures that all work is performed safely, legally, and ethically. Question 19. Consider a scenario where a journeyman plumber is installing a new hot water supply line using copper tubing. The available support locations do not perfectly align with the recommended spacing intervals outlined in the IPC for the given pipe diameter and material. The plumber has the option to slightly increase the distance between two supports to accommodate the existing building structure, or to meticulously reconfigure the installation to strictly adhere to the IPC spacing. What is the most professionally responsible course of action? Option A. Meticulously reconfigure the installation to strictly adhere to the IPC spacing requirements for pipe supports. Option B. Rely on past experience and general knowledge of pipe support to determine an acceptable spacing that is slightly wider than the code specifies. Option C. Slightly increase the distance between supports to accommodate the existing building structure, assuming it will not cause immediate issues. Option D. Install supports at the increased spacing, but make a note in the project log that the spacing was adjusted due to structural constraints. Correct answer is A. Meticulously reconfigure the installation to strictly adhere to the IPC spacing requirements for pipe supports. Explanation. This scenario is professionally challenging because it requires the journeyman plumber to make a critical judgment call regarding pipe support spacing that directly impacts the long-term integrity and safety of the plumbing system. Deviating from established code requirements, even with a seemingly minor adjustment, can lead to premature pipe failure, water damage, and potential safety hazards. The challenge lies in balancing practical installation considerations with the absolute necessity of adhering to the governing plumbing code, which is designed to prevent such issues. Careful judgment is required to ensure that any deviation, if absolutely unavoidable and permitted by code exceptions, is fully documented and approved. The correct approach involves meticulously consulting and adhering to the specific spacing requirements for pipe supports as mandated by the International Plumbing Code, IPC, or the relevant state/local amendments adopted in the jurisdiction. This approach is right because it directly aligns with the regulatory framework designed to ensure the safe and reliable operation of plumbing systems. The IPC, for example, provides detailed tables and guidelines for pipe support spacing based on pipe material, diameter, and fluid type. Adhering to these specifications prevents excessive stress on the pipes, minimizes vibration, and guards against sagging, which can lead to leaks and reduce system lifespan. This is a fundamental ethical and professional obligation to protect public health and safety by installing systems that meet or exceed code standards. An incorrect approach that involves arbitrarily increasing the spacing between supports, even if it appears to save time or materials, is professionally unacceptable. This failure stems from a direct violation of the IPC's prescriptive requirements for pipe support. Such an action disregards the engineering principles behind the code, which are intended to prevent undue stress and potential failure. The regulatory failure is clear. The installation does not meet the minimum safety and performance standards set by the code. Another incorrect approach, which is to rely solely on the installer's past experience without verifying current code requirements, is also professionally flawed. While experience is valuable, plumbing codes are subject to updates and amendments. Relying on outdated knowledge or personal judgment without consulting the current IPC can lead to non-compliant installations. The ethical failure here is a lack of due diligence and a failure to uphold the professional standard of staying current with relevant regulations. A third incorrect approach, which is to assume that a slightly longer span is acceptable because the pipe is carrying a low-pressure fluid, demonstrates a misunderstanding of the code's intent. The IPC spacing requirements are not solely based on pressure, but also on factors like thermal expansion, vibration, and the inherent strength of the pipe material. Ignoring these factors and making assumptions based on fluid type alone is a regulatory and ethical lapse, as it bypasses the comprehensive safety considerations embedded within the code. The professional decision-making process for similar situations should always begin with a thorough review of the applicable plumbing code, specifically the sections pertaining to pipe support and hangers. If there is any ambiguity or a perceived need for deviation, the plumber must consult the code's exceptions or seek clarification from the local building department or a qualified engineer. Documentation of any approved deviations is crucial. The guiding principle should always be to prioritize code compliance and system integrity over expediency or perceived cost savings. Question 20. Risk assessment procedures indicate that a homeowner is considering replacing their aging conventional tank-type water heater with a new system. They have expressed interest in tankless, electric, gas, and solar options, but are primarily concerned with energy efficiency and long-term cost savings. As a journeyman plumber, which of the following approaches best ensures regulatory compliance and homeowner safety while addressing their stated interests? Option A. Suggest a hybrid system that combines two different technologies without first verifying if such a system is explicitly permitted and has specific installation requirements outlined in the local plumbing code. Option B. Recommend the most energy-efficient system based solely on manufacturer specifications, regardless of existing infrastructure or local code restrictions. Option C. Install the system that the homeowner explicitly requests, assuming their choice is based on sufficient research and will meet all necessary safety and code requirements. Option D. Advise the homeowner on the operational principles, energy sources, and typical installation requirements for tank-type, tankless, electric, gas, and solar water heaters, and then guide them toward the most code-compliant and suitable option based on a thorough assessment of their home's existing plumbing, electrical, and venting infrastructure, as well as local plumbing codes. The correct answer is B. Recommend the most energy-efficient system based solely on manufacturer specifications, regardless of existing infrastructure or local code restrictions. Explanation. This scenario is professionally challenging because a journeyman plumber must ensure that the chosen water heating system not only meets the client's immediate needs, but also complies with all applicable plumbing codes and safety standards. The decision involves understanding the operational principles, energy sources, and installation requirements of various water heater types, and how these factors interact with local regulations. Careful judgment is required to balance client preferences, cost-effectiveness, and regulatory adherence. The correct approach involves selecting a water heater type that is permitted by the local plumbing code for the intended application and installation location, and ensuring it is installed by a qualified professional according to manufacturer specifications and code requirements. This is justified by the paramount importance of public safety and health, which is the core purpose of plumbing codes. For instance, gas water heaters have specific venting requirements to prevent carbon monoxide buildup. Electric water heaters must be properly grounded and wired to prevent electrical hazards, and tankless heaters require specific flow rates and pressure considerations. Solar water heaters may have additional requirements related to roof load, structural integrity, and integration with backup systems. Adhering to these regulations ensures the system operates safely and efficiently, preventing potential hazards like fires, explosions, electrocution, or water damage. An incorrect approach would be to prioritize client preference for a specific type of water heater, without verifying its suitability and compliance with local codes. For example, installing a gas water heater in a location where venting is impossible or inadequate would violate codes designed to prevent carbon monoxide poisoning, a severe health hazard. Similarly, installing an undersized or improperly rated electric water heater could lead to electrical overloads or premature failure, posing a fire risk. Choosing a tankless heater without confirming the existing plumbing can handle the required flow and pressure could result in inadequate hot water supply or damage to the plumbing system. Ignoring manufacturer installation guidelines for any type of water heater, such as improper pipe connections or inadequate support, can lead to leaks, water damage, and system malfunction, all of which are regulatory failures. Professionals should employ a decision-making framework that begins with understanding the client's needs and budget, followed by a thorough review of the applicable plumbing codes and manufacturer specifications for all viable water heater types. This includes assessing the existing infrastructure, gas lines, electrical capacity, water pressure, venting options, and the installation environment. The plumber must then recommend options that are code-compliant, safe, efficient, and meet the client's requirements, clearly explaining the pros and cons of each compliant option. If a client insists on a non-compliant or unsafe option, the professional must firmly refuse and explain the regulatory and safety reasons, documenting the interaction.